Hello friends, today we'll solve the control system problems of GATE 2023 Electronics and Communication paper. So this is the first question. It is saying that the open loop transfer function of a unity negative feedback system is Gs equal to K upon S1 plus ST1 1 plus ST2. Okay, where K, T1, T2 are positive constants, so we need to find the phase crossover frequency in radian per second. Okay, so phase crossover frequency uh, is denoted by omega pc, and it is that frequency at which the phase angle of the open loop transfer function become equal to minus 180 degree. So the method is first to put s is equal to j omega in the open loop transfer function, and then we need to calculate the angle of, so this will become g j omega h j omega, and then angle at omega is equal to omega pc is minus 180 degree. So this is just by the definition. So since we have gs, so we will put s equal to j omega everywhere. So this will be g j omega is equal to k, and then j omega 1 plus j omega t1 1 plus j omega t2. Okay, now we find the angle of each term. So this is constant, so it is 0 degree. This is j omega, so it is 90 degree. This is in first quadrant, both these are in first quadrant, so it will be tan inverse omega t1 upon 1, tan inverse omega t2 upon 1. Okay, then angle of g omega will be equal to, this is 0 degree, and these things will go to numerator side, so this will become minus 90 degree, then it will become minus tan inverse omega t1, and then this thing will become minus tan inverse omega t2, and then we equate everything to minus 180 degrees. So basically we get minus tan inverse omega t1 minus tan inverse omega t2 equal to, this thing goes this side, so it become minus 90 degree. So multiplying everything by minus 1, I get tan inverse omega t1 plus tan inverse omega t2 is equal to 90 degree. Now you can use the formula that tan inverse a plus tan inverse b is equal to tan inverse a plus b 1 minus ab. Okay, so this thing will be equal to tan inverse omega t1 plus omega t2 1 minus omega square t1 t2, and this is equal to 90 degree. So tan 90 is basically omega t1 plus omega t2 1 minus omega square t1 t2. Now tan 90 is what? So if you see the graph of tan theta versus theta, then at 90 degree it is equal to infinity. Okay, similarly at 270 it is infinity, similarly at minus 90 it is infinity. So this thing is infinity. Now this thing will become infinity when the denominator will become 0. So we equate the denominator to 0, so this will be equal to 1 is equal to omega square t1 t2, so omega square is equal to 1 by t1 t2, so omega will be only plus of under root t1 t2. Why not minus? Because it is frequency, so frequency is always positive. Okay, and since t1 t2 is already given to be positive, so we will only take the positive part. So this frequency is nothing but omega pc. So basically the value of omega pc is equal to 1 upon under root t1 t2. Okay, one thing about angle of complex number is that z can be like plus minus a, and then plus I times plus minus b. So a can be positive negative, b also can be positive negative. So whenever we need to find the angle, then first always find this alpha thing, which is tan inverse, and then mod b upon mod a. Okay, this you always find no matter what the quadrant, tan inverse mod b upon mod a. And then if it is first quadrant, then the theta is equal to alpha only. But if it is second quadrant, then it is pi minus alpha. If it is third quadrant, then you simply multiply this by 1, so then it will be minus pi plus alpha. And if it is fourth quadrant, then again you multiply by minus 1, so this is minus alpha. Okay, so this is the thing about quadrants and angle of a complex number. Second question is about block diagram. It is saying that in the following block diagram, RS and DS are two inputs. The output YS is expressed as YS is equal to G1S RS plus G2S DS. G1S and G2S we need to find out. So since there are two inputs, so one good approach to solve this question is using this block diagram only. So here it is R is coming, here it is Y is coming, so here Y will come, here y h will come. Okay, so this will be r minus y, and this will be, this d is coming, r minus y is coming, and y minus h is coming. So we will add these two and subtract these two, so here it will be d plus r minus y minus yh, and therefore output will be this multiplied by this gs, so g multiplied by d plus r minus y minus yh. So y is equal to gd plus gr minus gy minus gyh. Okay, now since we need to find the output y, so we will take y terms on one side, so y, and then this plus gy plus gyh is equal to gd plus gr. So now I take y common, so it will be 1 plus g plus gh is equal to gd plus gr. So y is equal to g upon 1 plus g plus gh d plus g upon 1 plus gh this r. Okay, so basically A is the correct answer. Or if you want to use the signal flow graph approach, then you can convert it into signal flow graph as this input node, then second, third, and then this fourth, and then this output node. 5 node we will take. Okay, so 1 2 3 4 5, and then first in case 1 we will find ys upon rs when ds is 0, because when I put ds equal to 0, then we will find ys upon rs which is equal to g1s. So g1s will be equal to y by rs. So when I put this thing as 0, then you can see there is only one forward path. Okay, so transfer function 1 will be, which is g1, will be p1 del 1 upon d. So p1 is forward path 1, p1 del 1 upon, then p1 delta 1 upon delta. So p1 is nothing but g only, there is no other forward path, otherwise it would be p1 del 1 plus p2 del 2 upon delta, but since there is only one forward path, so p1 delta 1 upon delta. Okay, so this transfer this thing is g, forward path 1, and then first we see delta, so it will be 1 minus sum of all individual loops. So there are two loops, this is g times minus h, and this is g times minus 1. So minus gh and minus g, and then sum of product of all two non-touching loops, so both the loops are touching, so this part is 0. So this is 1 minus of minus gh minus g, so this is 1 plus gh plus g. Okay, delta 1 is nothing but 1 minus sum of all individual loops which are not touching forward path 1. So since both the loop are touching forward path 1, so this is 1 minus 0 only. So basically g1, which is y by r, is nothing but g upon 1 plus gh plus g. Okay, similarly in part 2 I will put rs equal to 0 and I will find y upon d, because when I put rs equal to 0, then this term will become 0, so g2 will be y upon d. Okay, so here also you can see that there is only one forward path. Okay, so again transfer function 2, which is y g2, which is equal to y by d, is p1 del 1 upon p1 delta 1 upon delta. Now delta always remains same for a given signal flow graph, so again it will be 1 plus gh plus g only. Okay, and p1 is forward path 1 is nothing but again 1 into g into 1, so this is g into 1 minus sum of all individual loop which are not touching forward path, this forward path. So this loop is touching here, and this second loop is also touching here, so again it will be 0. So g2 is basically y by d, so which is g upon 1 plus g plus g upon 1 plus gh plus g. So again g1 g2 are same, therefore ys is equal to g upon 1 plus g plus gh times r plus g upon 1 plus gh plus g times d. So again we are getting option. So two ways of doing it. Third question is on error, steady state error. It is saying that a closed loop system is shown in the figure where k is greater than 0, alpha is greater than 0. The steady state error due to ramp input rs is equal to alpha upon s square is. So unity feedback system is given. Okay, so this this is the GS value. So we know the table for such questions, that type 0, type 1, type 2, where this type 0 means number of poles at origin in the GS. Type 1 means if there is one pole in GS which is at origin. Type 2 means if there is one pole at two poles at origin in the GS. Now here, since there is one pole at origin, so it is type 1 system. Okay, now this standard table is a step, ramp and parabolic. So it is a type 1 system and input is ramp. So we will find steady state error equal to alpha upon kV. Okay, this is alpha upon 1 plus kp, this is alpha upon 1 plus kv, and this is alpha upon 1 plus ka. Okay, now you can see that here kp is limit s tend to 0, s ki power 0 gs. kv is limit s tend to 0, s ki power 1 gs, and ka velocity error coefficient is limit s tending to 0, s square gs. Now we need to find kv. So kv is nothing but limit s tending to 0, s times the given gs. So s upon s times s plus 2, so k upon s plus 2. So s will cancel, and when I put s equal to 0, so it will be k by 2. Okay, so kv is known. So ess is nothing but alpha upon kv. So ess is alpha upon kv, so alpha upon 1 into k by 2 is 2 by kv, so 2 alpha by k. So this is 2 alpha by k. Okay, so here alpha was given. Usually it is unit ramp or unit parabola or unit step, but if alpha is also there, then you simply introduce alpha here also in ESS values also. Okay, that's the only thing. So correct answer is 2 alpha by k. If unit ramp was then ESS would be 2 by k. Okay, so since it is a linear system, so if alpha is multiplied in input signal, then alpha is also multiplied to output signal and also to steady state error. Okay, so again an easy question. Another question is on body plot. It is saying that the asymptotic magnitude body plot of a minimum phase system is shown in the figure. The transfer function of the system is s equal to k s plus z ki power a divided by s ki power b times s plus p ki power c, where k, z, a, b, c are positive constants. Value of a, b, c is. So whether you write it in time constant form or you in pole zero form, it doesn't matter, because we just need to find the values of these powers, so it doesn't matter. So if we write it in pole zero form, then it will be transfer function will be k times s plus. So first you see that there is a slope of minus 20 dB per decade initially. So this means there was a pole, there is a pole of order 1 at origin. Okay, so b will become 1, then the slope is changing to 0 dB, which means now there is a 0 at omega is equal to omega 1, and it is of order 1. Okay, so 0 at 1, and then again at omega 2 you can see that the slope is changing to minus 40 dB per decade. So there is a pole of order 2 at omega 2. Okay, so in this pole zero form, you can write it as s plus this thing is omega 1, and then s, and then it is s plus omega 2 square. This thing is 1, this thing is 1. Or if you want to write it in time constant form, which is always preferred when we need to find the value of this k also, so then it will be k1 plus s tau 1 s1 plus s tau 2, where tau 1 is nothing but 1 upon omega 1. So this will be k 1 plus s upon omega 1, s ki power 1 1 plus s upon omega 2, plus here also the power will be same only na? This is the corner frequency. So in time constant form we introduce this corner frequencies in denominator. Okay, omega 1 and omega 2, but in pole zero form we directly write them like omega 1 omega 2. That is the main difference. So here he is asking them in pole zero form, so but but it doesn't matter, the power will still be same only. 1 plus 1 plus 2, so this will be 4. Okay, but if you need to find the value of k also, or DC gain, then you can see that we need to use this form. So in many times in gate question they ask this form, so this is also important. Okay, last question is on state space. It's a theoretical question. State equation of a second order system is x dot is equal to axt. X0 is the initial condition. Suppose lambda 1 lambda 2 are two distinct eigenvalue of v1 v1 v2 are corresponding eigenvectors of a constant alpha 1 alpha 2. The solution xt of the state equation is. So usually we know that from state model it is x dot is equal to ax plus bu. Okay, but here there is only x dot is equal to ax, so it means there is u is equal to the input thing is 0, so it's a 0 input system. Okay, so 0 input response is asked, which means the output only due to the initial condition. Okay, so for such a system we know that 0 homogeneous system or 0 input response or natural response type of system which are written as x dot is equal to axt, solution is xt is equal to phi t dot x0. Okay, so this is the straight transition matrix, and I multiply the initial condition to it, then we can find the output at any time t. But he is asking this output in terms of eigenvalue and eigenvector. So how do we do it? So here x0 can be, it's a column vector only, so it can be treated as a eigenvector. This column vector x0, this x0 can be written as alpha times v1 plus alpha times v2, because lambda 1 lambda 2 are two distinct eigenvalues, so v1 and v2 will be independent eigenvectors. So we can write this x0 as a linear combination of two independent eigenvector. Okay, so this is the thing that I'm using here. So x0 can be written as alpha v1 plus alpha v2, and this straight transition matrix can be written as e ki power at also. You know that straight transition matrix is phi t is inverse Laplace of si minus a inverse, or it is also written as e ki power at, which using this Taylor series expansion is I plus at plus a square t square by 2 factorial plus a cube t cube by 3 factorial, so on. So these are different ways of writing straight transition matrix. Okay, so x0 I am writing as a linear, this column vector I am writing as a linear combination of two independent eigenvector. Okay, and phi t is equal to e ki power at. These are same thing, so this can be written as alpha 1 e ki power at v1 plus alpha 2 e ki power a2 v2 at v2. Now I know that if a has eigenvalue lambda I and eigenvector vi, then e ki power a has eigenvalue e ki power lambda I, and but eigenvector will still be vi. And if I multiply by t, then the eigenvalue will be lambda I t and eigenvector will be still vi. Okay, so just like ax is equal to lambda x in maths, a times vi is equal to lambda I times vi. So this is the eigenvector equation. Now e ki power, therefore e ki power a vi will have eigenvalue e ki power lambda I times the eigenvector. This I can write. Okay, because if a has eigenvalue lambda I, then e ki power a matrix will have eigenvalues e ki power lambda I, and eigenvector will remain same. So when I multiply a by t, then here also I will multiply a by t. So e ki power at vi is equal to e ki power lambda I t vi. So this I will use here. So it will be alpha 1 e ki power at vi. I am using this as e ki power t vi as lambda I t v1 plus alpha 2 e ki power lambda 2t v2. Okay, so this is our final result which we want in terms of eigenvalues and eigenvector. So this is option number A, which is alpha 1 e ki power lambda 1t plus alpha 2 e ki power lambda 2 v2t. So this we usually do not remember, we only remember this part, but this time they asked in terms of eigenvalues and eigenvectors, so we should know how to write it in terms of eigenvalue and eigenvector also. also. So this way also we can write, and we should remember it for future. Okay, so is the correct answer. So these were all the 5 questions. All were pretty easy. Thank you.